Alright team, let's talk about something truly epic: wetlands. These places are some of the most important habitats on our entire planet. Think of them as nature's superheroes. They are soggy, muddy, and absolutely teeming with life. From vast marshes stretching for miles to the boggy pond at the end of your street, wetlands are everywhere. They are a crucial home for an incredible diversity of creatures. Birds, fish, insects, and amphibians all depend on these watery wonderlands for food, shelter, and a place to raise their young. Without healthy wetlands, so much of the wildlife we love would simply disappear. But their job doesn't stop there. Wetlands are also the Earth's giant sponges and filters. When heavy rains come, they soak up all that extra water, which helps to prevent floods in our towns and cities. They act like a massive natural barrier protecting the land around them. As the water passes slowly through the mud and tangled roots of the plants, it gets cleaned. They trap pollutants and sediment, making the water that flows out the other side much clearer and healthier for everything that depends on it downstream. It's a brilliant natural purification system that works tirelessly, day and night. These wild places are also powerhouses when it comes to fighting climate change. The plants and soil in wetlands are experts at capturing and storing carbon from the atmosphere. They lock it away in the ground, preventing it from contributing to the warming of our planet. It's a vital service that often goes unnoticed. So you see, these aren't just muddy puddles. They are complex, dynamic ecosystems that are working hard for the health of our world. They are just as important as rainforests or coral reefs, and they are packed with adventure and discovery for anyone brave enough to explore them. That's why understanding how they work is so important. And what better way to do that than to build one ourselves? We can shrink down one of these amazing habitats and create our very own mini wetland inside a simple glass jar. This isn't just a cool experiment, it's a window into a hidden world. By building it, we can get up close and personal with the fundamental principles of nature. We can watch a tiny ecosystem come to life, find its balance, and see firsthand how every single part, no matter how small, has a massive role to play in the grand scheme of things. So, how do you capture the magic of a massive wetland in a little jar? It's all about getting the layers right. Our first mission was to find a large, clear glass jar, something big enough to give our ecosystem some room to breathe. The first layer we put in was crucial, a base of small stones and gravel. This layer is the foundation of our world. It's not just for show, it creates important pockets of space. This drainage layer ensures that the soil above it doesn't become a solid waterlogged block of mud, which would suffocate the plant roots and kill our ecosystem before it even started. Next up, we added a thin layer of activated charcoal on top of the stones. This might seem like a strange ingredient, but it's our secret weapon for keeping things fresh. Charcoal is an incredible natural filter. In a closed environment like our jar, things can get a bit smelly and stagnant over time as organic matter breaks down. The charcoal acts like a purifier, absorbing impurities and odors from the water. It helps to keep the water clear and the whole system healthy, preventing the buildup of nasty bacteria that could throw everything out of balance. It's like giving our mini-world its own water treatment plant. The third and most important layer was the soil itself. We didn't just use any old dirt from the garden. We collected soil and mud directly from the edge of a real, local pond. This was a critical step because this soil is more than just dirt, it's alive. It's packed with a hidden world of microscopic organisms, tiny seeds and dormant eggs of minuscule creatures. This is the lifeblood of our jar, the source code for the ecosystem we hope to create. By using this special soil, we were giving our jar a head start, introducing the very building blocks of a functioning wetland food web from day one. Finally, it was time for the water and plants. We carefully poured in pond water, again sourced from the same location as our mud. This water contains its own community of microscopic life like algae and protozoa. Then we carefully planted a few small aquatic plants we had collected, things like duckweed, and a small piece of hornwort. These plants are the lungs of our jar. Through photosynthesis, they would produce oxygen for any tiny creatures to breathe and would use up nutrients in the water, helping to keep it clean. With all the layers in place, we sealed the jar and put it in a spot with indirect sunlight, ready to watch our new world unfold. With our mini wetland assembled and sealed, the great waiting game began. What did we expect to see? Our hope was to witness the creation of a self-sustaining, balanced ecosystem. In a perfect world, the plants would thrive, releasing tiny bubbles of oxygen into the water during the day. This oxygen would support any microscopic animals that hatched from the eggs hidden in the pond mud. We watched closely for the first signs of life. Perhaps a tiny water flea darting through the water, or a minuscule snail slowly making its way across the glass. The ultimate sign of success would be crystal clear water, indicating the plants and microorganisms were effectively filtering waste. For the first week, not much happened. It was a still, quiet world of mud and water. But then, slowly, the magic started. The duckweed on the surface began to multiply, forming a delicate green carpet. The hornwort plant seemed to stretch out, its feathery fronds reaching towards the light. We spotted the first inhabitants, a few tiny worm-like creatures wriggling in the soil, and then a single solitary pond snail, no bigger than a grain of rice, appeared on the glass. It was an absolutely thrilling moment. Our jar was no longer just a collection of ingredients, it was a home. Life was taking hold. As the weeks turned into a month, the ecosystem truly came alive. The population of snails exploded. We could count over a dozen of them, constantly grazing on the thin layer of algae that was starting to form on the inside of the jar. They were our cleanup crew, keeping the glass clear and recycling nutrients. We also noticed other, even smaller creatures known as copepods and ostracods zipping around in the water column like tiny specks of dust. These critters were feeding on algae and bacteria, forming a vital link in our miniature food web. The water remained remarkably clear, a testament to the hard work of the plants and snails. Our initial hopes were being realized. The jar had found a delicate equilibrium. The plants produced oxygen and consumed waste. The snails and other micro-critters consumed the algae and decaying plant matter, keeping the system clean. Their waste, in turn, was broken down by bacteria in the soil, releasing nutrients that fertilized the plants. It was a perfect closed loop. We had created a tiny, living world that was taking care of itself. A beautiful demonstration of how a healthy ecosystem functions, with every single organism playing its part in maintaining the balance. It was nature's intricate dance, happening right there on our windowsill. However, nature is rarely stable forever. After about 2 months of beautiful balance, we noticed a change. A patch of fuzzy white mold started growing on a decaying leaf at the bottom of the jar. At the same time, the water began to take on a slightly cloudy appearance. The system that had been so perfectly balanced was beginning to struggle. We hadn't changed anything, but something inside had shifted. The snail population, which had boomed, seemed to be producing more waste than the bacteria and plants could process. This excess of nutrients was likely feeding the mold and causing an algal bloom, which was making the water cloudy. And this shift was a powerful lesson. It showed us just how fragile ecological balance can be. Even in our simple, sealed jar, a small change, in this case too many snails for the system to support, could start a chain reaction that threatened the health of the entire world inside. The system was tipping out of balance. It was a stark reminder that in any ecosystem, from our jar to a vast ocean, population sizes matter. Too many of any one thing, even a helpful grazer like a snail, can overwhelm the natural checks and balances that keep everything running smoothly. We decided not to intervene. Part of the experiment was to see how the system would respond to challenges on its own. Over the next few weeks, we witnessed a natural correction. The cloudy water and excess waste led to a decline in the snail population, as there was less oxygen and a buildup of toxins. As the number of snails went down, the pressure on the system eased. The water slowly began to clear up again as the plants and remaining microorganisms caught up with the cleaning. The mold disappeared. The jar didn't return to its original state, but it found a new, different kind of balance. This entire journey with our wetland in a jar taught us more than any book could. We learned that ecosystems are not static, they are dynamic, constantly changing and adapting. We saw firsthand the crucial roles played by producers, like plants, consumers, like snails, and decomposers like bacteria and mold. Most importantly, we learned that balance is not about things staying the same, but about the ability of a system to respond to change and find a new equilibrium. Our little glass world showed us the resilience and complexity of nature, proving that even in the smallest of spaces, the fundamental rules of life are playing out in an epic and fascinating story.